All right, welcome back, everybody. This is the last topic of this unit on trigonometry, and it's going to be a little bit difficult. We got a couple of proofs to go through, and we'll do some examples to go along with them. But the good news is that after learning these two new theorems, law of sines and law of cosines, you're going to be able to solve any triangle. So you see that written there on the screen there. Again, we're going to learn two new triangles or two new theorems, and that's going to enable you to solve any triangle in the universe. Okay, looking at the triangle I have drawn here, so you see triangle ABC. We're going to prove the law of sines first. So as usual, small a is across from angle A, small b is across from angle B, and side small c is across from angle C, with the height h in there. Now this is not necessarily a right triangle here. It doesn't have to be. So we're going to focus our attention then on this first triangle on the left here. So sine of angle A, as we know, is opposite leg h over hypotenuse. So h over b. There's your first equation. And then focus your attention on the second triangle here on the right. Sine of angle B equals opposite leg h over a. So that gives us two equations here. And we're going to solve each of those equations for h. So this first one, if you solve it for h, would be b times the sine of angle A. And if you solve the second equation for h, it would be a times the sine of angle B. Just multiplying both sides by a there. Notice both these equations are solved for h, so we can set them equal to each other. And that's what I did right here. So b times the sine of angle A equals a times the sine of angle B. Now, if you divide both sides by the sine of angle A and the sine of angle B at the same time, you'll have this proportion right here. So again, I took this equation right here and divided both sides by the sine of angle A and the sine of angle B at the same time. That's how we get this proportion. This proportion could be extended. If we had started with a different altitude on that original triangle, we would actually be able to extend this proportion to one more side and angle. And so you would have, if you did that, you would have this statement. This is the law of sines, and it says any side of a triangle divided by the sine of the angle opposite that side, so in this case, side A and sine of angle A, will be equal to side B and the sine of angle B, so another side angle pair. And that's also equal to the third side of the triangle, which I called C, and the sine of the angle opposite that. So these ratios are true for every side angle pair in a triangle, and that's called the law of sines. Well, how does it work in the real world? Well, here you go. Here's a triangle. We want to find side E there. Find side E. So we're going to set up a proportion in which case we take a side, which is E, and divide it by the sine of the angle opposite that side, so the sine of 32 degrees. And then we're going to set that equal to another side angle pair, so 18, divided by the sine of the angle opposite it, so sine of 105. So there's your proportion. Just going to solve it like we always do by cross multiplying. So that's going to give us E times the sine of 105 degrees equals 18 times the sine of 32 degrees. Let's divide both sides by the sine of 105 to get E by itself. So E equals 18 times the sine of 32 degrees divided by the sine of 105 degrees. Now, you should be able to do that problem completely in your calculator without writing it down to any intermediate results. So I'm going to do that right here. So sine of 32 times 18 equals, so that when you hit equals, that calculates the top, then divided by sine of 105. Don't forget to hit equals. So E is going to be 9.7. Actually 9.9. 9.87 rounds up to 9.9. So we just found then in this triangle, this side right here, 9.9. Okay, let's do another law of sines problem. There's another one. This time we're trying to find the measure of angle S. So we're looking for an angle this time, but you're still going to use law of sines. So we're going to set up a proportion. So you see another side angle combination. So side 7. So 7 divided by the sine of 75 degrees equals 5 over the sine of angle S. So S is your variable, angle S is your variable. Solve like we always do, cross multiply. So you got 7 times the sine of angle S equals 5 times the sine of 75 degrees. All right, let's divide both sides by 7 to get the sine of S by itself. So 5 times the sine of 75 degrees divided by 7. Okay, so I'm going to write that decimal here on the right side because remember, we got to use inverse sign here to get angle S. So I'm just going to calculate that decimal there on the right side. You can't see me do it. I'm on my old school calculator. So 75 degrees sine times 5 divided by 7 equals. So this right side is going to be 0.68997. Leave that number in your display. Don't clear it out because you'll lose accuracy. And just take the inverse sign. So that angle S is inverse sine. It's going to be 43.6 degrees. 43.6 degrees. So you just found this angle right here by using the law of sines. Okay, let's do law of cosines. Law of cosines is a bit more complicated in the proof. By the way, ignore that horizontal blue line there. That shouldn't be there. It's an artifact. You have triangle ABC here. You see that? And so the usual sides, small a, small b, small c. You got the altitude h. Again, this triangle ABC does not have to be a right triangle. It could be any triangle. And then these two parts of side AB are going to be x and then c minus x, right? Because c is the entire length. C minus x would be the part that's not the x. Okay. Off to the side in blue ink here, I wrote some facts about this, and then we'll get into the proof. The facts concern this triangle on the left here. So if you remember Pythagorean theorem, you got x squared plus h squared equals b squared. You see right there, x squared plus h squared equals b squared. We'll keep that right there for a minute. Now look at the cosine of angle A. That's adjacent leg x divided by hypotenuse. So cosine of angle A equals x divided by b. You got that right there. And then if you take that equation, that cosine equation we just wrote, and solve it for x by multiplying both sides here by b, then you'll have x equals b times the cosine of angle A. Okay, put those on hold for a minute, and we're going to come back and use both of them. Okay, now focus your attention on this triangle on the right here. So it's a right triangle, so we can use Pythagorean theorem on it. So c minus x, that's this leg right here, c minus x quantity squared plus h squared, that's the other leg, equals a squared, the hypotenuse. Okay, so this first line here in green ink is the Pythagorean theorem applied to this triangle on the right. Okay, next step, second step, all I'm doing there is squaring out this binomial. So you might have to think back to Algebra 1 or Algebra 2, if you've had that, on how to square out a binomial. But it's c minus x times c minus x. That'd be c squared minus 2cx plus x squared. Then I recopied the rest, plus h squared equals a squared. Now the third step here, think back to your facts there in blue. This x squared plus h squared, we already said was equal to b squared. So we're going to make that substitution right here. This x squared plus h squared is going to be now b squared. So I wrote right here in the third line. So now we have c squared minus 2cx plus b squared equals a squared. This fourth line of the proof is really just rearranging the terms. I put the a squared on the left side and switched over the terms around a little bit so that we've got a squared equals b squared plus c squared minus 2cx. So nothing new there other than just rearranging terms. Now look at that'd be the fifth line there. A squared equals b squared plus c squared minus 2c. This x got replaced by b cosine a. Remember back in your blue facts here, we said x was equal to b cosine a. That got replaced down here for x. So x got replaced by b cosine a. And so that leaves us with this last line, which is the law of cosine. So a squared equals b squared plus c squared minus 2bc cosine a. It's kind of long. If we had started the problem in a different way, we would have two other versions of the law of cosines. I'm not going to prove them. They look very similar, as you can tell. The second version is b squared equals a squared plus c squared minus 2ac cosine b. And the third version is c squared equals a squared plus b squared minus 2ab cosine c. So you can look at the three versions, and each one has an angle, a different angle. And so that's going to come in handy when you go to solve some triangles here. Okay, so how does this law of cosines actually work? Okay, so look at this example. By the way, you might be wondering, how do I know when to use law of sines and when to use law of cosines? Well, the answer is that start with the law of cosines. Start with the law of sines if you can, because it's easier to use. If it's impossible to use the law of sines, then switch over to law of cosines, and then that should work for you. So we're trying to find side A in this triangle right here. So notice we don't have any side angle combinations. We got side A. We don't have side A, but we have angle A. We have side C, but not angle C. We have side B, but not angle B. So we can't use law of sines here. So we're going to have to use law of cosines. Okay, so here's the law of cosines, the version I'm going to use here. So it's a squared, because we're looking for A, equals b squared plus c squared minus 2bc cosine of angle A. So now we got to plug all that information in and then use our calculator. This is a great calculator exercise. So a squared, we don't have A, so we're going to write a squared. B squared is the 9 squared, right? Plus c squared, that's going to be the 14 squared, minus 2 times b, which we said was 9, times c, which we said was 14, times the cosine of A, and we know A is 62 degrees, so cosine 62 degrees. So to calculate A, it's the square root of that whole mess on the right side. So here you go. This is a big calculator problem, and I'll tell you how I solve it. And you can do it all in the calculator. Just recopy now the part under the radical. You do have to be careful as you're doing this, though, because one bad keystroke means you got to start over. First of all, make sure you're in degree mode. Okay, so I'm actually going to do the square root last here. I'm going to do the part under the radical on my calculator. You're not going to see it here because I'm working on my calculator, old school calculator, but I'll tell you what I'm doing. And then the last thing I'm going to do is take a square root of the whole thing. So I got 9 squared. Most calculators have a square button, so 9 squared plus 14 squared minus just what you see there, minus 2 times 9 times 14 times cosine 62 equals. Okay, now I got that, and now I'm going to take the square root and just give you the final answer. That number is 158.69. Square root of that, 12 point, I'm going to round it up to 12.6. Okay, so there you go. Did it all in the calculator. You didn't see it, but it was all in the calculator. Never wrote down anything. You can do that if you're careful. So you just found right there this side A here. Okay, let's do one more problem, law of cosines, and that'll wrap it up. Again, first check to see if you can use law of sines. If you can't, you got to use law of cosines. Notice I don't have any angles in this triangle. There's no way I can use law of sines to start this problem. I don't know any angles. So I'm going to use the version of law of cosines which said cosine of A in it because we're looking for angle A. That's the one that goes like this, a squared plus b squared, a squared, let me do that over again. A squared equals b squared plus c squared minus 2bc cosine of angle A. Let's fill in the A, B, and the C because we have all of them. A is 9, so 9 squared. This one's a little bit trickier with your calculator for sure. Equals b squared, so that's 7 squared, plus c squared, which is 4 squared, minus 2 times b, which was 7, times c, which was 4. And we don't know A, so cosine of A. Now I'm going to do some algebra here, some tricky algebra maybe for some people, and then we're going to get cosine of A by itself, and then we'll get that decimal, and then we'll take inverse cosine. So I'm going to try to solve this for angle A. First of all, I'm going to subtract, well, you'll see what I'm doing, 9 squared minus 7 squared minus 4 squared. I'm going to stop right there for a minute, equals negative 2 times 7 times 4 times cosine of angle A. Okay, now to get that cosine of A by itself, I'm actually going to divide both sides by negative 2 times 7 times 4. Okay, so we got 9 squared minus 7 squared minus 4 squared divided by negative 2 times 7 times 4. Those are all now gone from the right side. That's equal to cosine of A. So when I do the left side on the calculator, that'll give us a decimal, and then, like I said, we're going to take inverse cosine. This is very tricky. You can do this on your calculator all at once, but you got to make sure you do the keystrokes correctly. So I'm going to go through those. I'm just switching sides right now. Cosine of A. Okay, so I'm going to do the top first. So 9 squared. So 9 squared minus 7 squared minus 4 squared. Now you got to hit equals. You got to hit equals. Otherwise, you're not ready for the bottom yet. Then I'm just going to do 3 division problems. Divided by negative 2, divided by 7, divided by 4 equals. Okay, so this cosine, I don't know if I did that right. Let's see. Yeah, I did. I think I'm okay on that. Is a negative 0.2857. 143. I'll just write those out there. And so now I'm going to hit inverse cosine. So angle A, inverse cosine gives 106.7 degrees. The reason I was scared a minute back there was the cosine came out negative, and what that's going to mean is your angle is going to be bigger than 90. But that's for pre-calculus. So right now, if you just follow that law of cosines, you'll get that angle. So that angle A is 106.6 degrees, and you can see that it is obtuse. So that's the angle we found, 106.6 degrees. Okay, so this is going to be a bit of a challenge, I think, on the homework. So let me just summarize a little bit here. Law of sines and law of cosines. Rather than maybe just telling you what it is or how to prove it again, is the law of sines is in any triangle, the ratio of any side divided by the sine of the angle opposite holds true for every side angle combination, every side angle pair. So again, law of sines, any side divided by the sine of the angle opposite is consistent for every side angle pair. And then law of cosines is the 3 big equations. It's kind of hard to describe that, but the 3 big equations that we wrote. And just as a strategy, remember that if you see a triangle and it just says solve it, you want to use the law of sines first because it's easier. So you're looking for side angle pairs for that. But if you don't have that, you're going to have to turn to law of cosines and solve it that way. Okay, so you definitely got to work some of these problems to get practice on it, but we're going to get practice. So let's start that, and good luck.